Alrighty, lesson 9-2 trigonometry. So, the definition. Trigonometry is a branch of mathematics concerned with relationships between angles and ratios of lengths. A trigonometric ratio is a ratio between two sides of a right triangle. Now, in this course, we will focus on the fundamentals. We're going to be focusing on three ratios: sine, cosine, and tangent. Okay, so for acute angle A in a right triangle, the trigonometric functions are sine of angle A. We call angle A the angle of reference. So the sine of angle A, here's angle A, it is the length of the opposite leg over the hypotenuse. Or we can just say sine of A is equal to op over hyp, okay, or O over H. So this is my angle of reference, so this is the opposite side, and it's going to be over the hypotenuse. The cosine of angle A is equal to the length of the adjacent leg over the length of the hypotenuse. Or, again, this is angle A, that's my angle of reference right there. The cosine of A is adjacent, meaning next to. So this angle is next to this side here over the hypotenuse. Okay, so it's adjacent over hypotenuse. Now the hypotenuse, I assume you already know what the hypotenuse is because we talked about this a lot. The hypotenuse of a right triangle is the longest side. It's always across from the 90-degree angle. So this is the hypotenuse, okay? So the ratio, when you're dealing with the cosine of A is adjacent over hypotenuse. Now the tangent of angle A is the length of the opposite leg over the length of the adjacent leg. So it's O over A. So the tangent of A is opposite over adjacent, right? That's basically saying O over A, and then over here, this is A over H. That's for cosine of A, okay? So that's great. We have all these ratios, but that's too much. So we have a mnemonic device, something that will help us remember all of these ratios, and it's this weird mnemonic, and it's going to stick out to you. It's called SOHCAHTOA. If I break down the SOHCAHTOA, if I break it up, well, this means sine is the ratio between the opposite leg over the hypotenuse leg. Okay, so again, it's sine of something. I'm going to call it theta. That's my angle of reference. That's a Greek letter. Sine of theta is equal to opposite over hypotenuse. Okay, or maybe instead of saying theta, I would just say sine of, let's just say A. Why not? Or any angle of reference. So sine of A is equal to opposite over hypotenuse, and then ca, you see that C, we're talking about cosine, right? And cosine of A is equal to adjacent over hypotenuse. And then lastly, the TOA, the T for tangent, that's tangent of A, is equal to opposite over adjacent. Okay, so hopefully remembering the SOHCAHTOA will allow you to work through these problems, and you don't have to sit there and think through or go back to your reference sheet so much. But if only you know what SOHCAHTOA, you wouldn't waste so much time. That's what I'm trying to say, okay? All right, let's go ahead and practice. So let's express each of the following as a fraction and a decimal. Round to the nearest hundredths. Round to the nearest hundredths. So, always, my rule of thumb is to write SOHCAHTOA for trig problems. So, here is my triangle. This is my right triangle, and it has side lengths, it has angles. That's awesome. We have sine of P. Now, P is my angle of reference. I'm going to say angle of ref. I'm going to find where P is, and I'm going to circle it. Because that's where you're going to be using, that's where you're going to be starting off with. So, we have to label this figure. So always label. Always label your figure. Which one's opposite? Which one's adjacent? Which one's hypotenuse? Well, if I say across from P, this side has to be the opposite side. That's really, really easy. And if I were to say this side, well, this is the hypotenuse. Why is this the hypotenuse? Because it's across from the 90-degree angle. Non-negotiable. The side across from the 90-degree angle is always the hypotenuse. So if you have opposite hypotenuse, then you're left with one more thing, and that is the adjacent side. Don't forget the adjacent side. Okay? So this is adjacent. It's always next to the angle. So this here is adjacent. Okay? Now, I have SOHCAHTOA. I'm not going to write SOHCAHTOA for these problems here because it's already right here. It's a sine of P. Now, sine, that means I'm using SOH, or so, where S means the sine, O means opposite, and H means the hypotenuse. So sine of P is equal to opposite over hypotenuse. And y'all, if we look, the opposite side is 15. So I'm going to write 15. And then the hypotenuse is 17. So it's 15 over 17. That is my answer as a fraction. In fact, this is a simplified fraction, and that's awesome. That's it. In terms of being a fraction, that is. But what we now need to do is I need to express this as a decimal, okay? So using my calculator, I highly encourage you to download Calculate 84. I'm going to clear the memory right now. 2 plus 7, 1, 2. There's an advertisement there. Great. I'm going to put 15 divided by 17. And 15 divided by 17 is 0.8823. So I'm rounding to the nearest hundreds. So just looking at the second 8 after the decimal, the 2 dictates the 8. So my answer is really approximately 0.88. 0.88, okay? All right, I'm gonna move this calculator away. Okay, I think this is actually good. This is a good screen. So cosine of P. Now, cosine, if we look at this, that's co, right? So cosine is equal to adjacent over hypotenuse. So I will write cosine of P is equal to the adjacent over hypotenuse. And the adjacent side is 8, and the hypotenuse is 17. So using my calculator, 8 divided by 17, that's 0.470. Round to the nearest hundredth. That 0 is going to dictate that 7, but the 0 doesn't really change the hundredth place or hundredths place at all. So that's just approximately 0.47. Okay, that's your answer. Tangent of P. Tangent of P. So what I'm going to do is I go back to SOHCAHTOA. Tangent says opposite over adjacent. That's what I'm going to write. So tangent of P is equal to opposite over adjacent. What's the opposite side, or what's the measure of the opposite side? That's 15. And the adjacent side is 8. So using my calculator, I 15 divided by 8, round to the nearest hundredths. That is 1. So it's approximately 1.88. And that's your answer. Hopefully things are making sense right now. Good. Let me see if I can move the calculator to the left hand. I'm right-handed, so I don't want to fat finger stuff or anything like that. So there you go. All right. Now we are using a different angle of reference. And what I'm going to do is On your paper, and also my, PDF, we have only one triangle, and they share all of these problems here. So what I'm going to do, instead of confusing, and, we're going to have to relabel everything, because we have a different angle of reference. I'm just going to redraw this picture. So let's redraw that picture. So here's my right triangle. And this is Q, R, P. It's a right angle, 17, 15, and 8, okay? There you go. So let's go ahead. I'm going to use a different color. What's the angle of reference? It's Q, right? It's Q. So it's Q. Across from Q, this is the opposite side. So 8 is the opposite side. This is the hypotenuse. And then this here is, of course, the adjacent side, because it's next to, right? So adjacent. So sine of Q is equal to opposite over hypotenuse. O, in this case, is not 15. It's actually 8. And then the hypotenuse is 17. So 8 divided by 17, that is approximately 0.47. And then cosine of Q, that's adjacent. So cosine of Q, that's adjacent over hypotenuse. Your adjacent side is 15. And your hypotenuse, so 15, and your hypotenuse is 17. So 15 divided by 17, 15 divided by 17, that is approximately 0.88. So 0.88, okay? If I can write those two 8s, there you go. And then lastly, tangent of Q. Tangent of Q. So that's opposite over adjacent. So tangent of Q is opposite over adjacent. And the opposite side for this scenario is 8. And your not hypotenuse, your adjacent side is 15. So you have 8 divided by 15, that is 5.33. There you go. Alrighty. So that's the first page of the notes. Okay, so let's go ahead and take a look at the next page. It's just use special right triangles to express the tangent of 30 degrees and cosine of 45 degrees as fractions. So tangent of 30 degrees, I'm going to rewrite that as tan of 30, where this 30 is my angle of reference. And over here we have the cosine of 45, which I'm going to rewrite as cosine of 45, where again, just like before, this 45 is my angle of reference. So let me go ahead and look at this particular triangle. I gotta find the tangent of 30. So since 30 is my angle of reference, this here is my angle of reference. That's what I'm going to circle. I'm going to start there, and then I'm going to start labeling my picture. So across from 30 degrees, I label this as opposite. And then this side here is my hypotenuse, because it's across from the 90-degree angle. And then lastly, this side here is adjacent, because it's next to, or I should say the 30 degrees is next to this side, therefore it's adjacent. So when I'm talking about tangent of 30, so if I'm talking about tangent of 30, let me write SOHCAHTOA up on my paper, just right here. So we know that tan is, I didn't mean to write it like that. Hold up. That's going to be TOA. There you go. If I'm talking about tangent of 30, I'm using opposite over adjacent. So here's opposite. Here's adjacent. So here's adjacent. So it's O over A And the opposite side is x. And the adjacent side is x root 3. So I can go ahead and cancel, because I have x divided by x, ignore the root 3 for now, we have x divided by x, that's going to cancel. So these two x's will go away, so x divided by x is going to be 1, right? So that's going to be equal to 1 root, now I'm going to go ahead and put that root 3 in the denominator. So 1 divided by root 3, I can't leave that as my answer, I have to rationalize, so I got to multiply the bottom and top by root 3. So that equals root 3 over 3. And that is your answer. That is the tangent of 30. Okay, so now I'm going to look at this special right triangle. So I have a 45, 45, 90. The cosine of 45 is being mentioned, so I write cosine of 45. I'm going to use SOHCAHTOA again, and then I'm going to look at, okay, so we have two 45-degree angles here. I'm going to pick one. Oops. I'm going to pick one. This is going to be my angle of reference. I'm going to start label. So this here, that's my opposite side. This here is my hypotenuse. And then lastly, this is my adjacent side. So since I'm dealing with cosine, I should look at ca, which means that is equal to adjacent over hypotenuse. So the adjacent side is L, and the hypotenuse is L root 2. So then I'm going to cancel the two L's. I have 1 root 2, then we'll multiply the top and bottom by root 2, so that's root 2 over 2. The cosine of 45 is root 2 over 2. Okay, so now in this part of the notes, we will require a graphing calculator. If you do not own a graphing calculator, you can download the app Calculate 84, which you can see that I have right here on your screen, left-hand side of the video, this calculator here, that's called Calculate 84. It's super helpful, especially when I'm making these notes video, and especially when I'm teaching the class. This is a game changer, especially when you don't have that physical graphing calculator that you don't have potentially. This is completely free. You can download it. I have QR codes. Go ahead and whatever device that you have, scan the appropriate QR code and download the app and follow along through the notes. You need to know how to use the calculator here. Okay, let's learn how we should set up your graphing calculator. So on your graphing calculator, we need to make sure our calculator mode is in degrees. How do we do that? Here are your steps. First of all, on your calculator, find the mode button. I'm going to press mode, which is next to the second button. Okay, you can see that light blue button, that's second. Right next to it is the mode button. Now you're going to scroll down and make sure that you are not highlighting radians or radian, that's pre-cal. You need to make sure it's in degree, and we'll talk about radians in pre-cal if you're going to take pre-cal, but for now in geometry we're going to be working our calculator in the mode of degree. So press enter there, make sure it's highlighted. Now let's exit the screen. How do we do that? We're going to press second mode so we can quit. Okay, so now you've set up your calculator. We can go ahead and answer some of the problems here. Look at this triangle. It says find the value of x in each of the following. Don't forget to label the sides. Take a look at this triangle here. What do we notice? We have two sides and an angle, or I should say, well, technically there are three sides, 1, 2, 3, but we have two given sides and one angle. So this is what I'm going to do. When you're dealing with this type of problem, look at the angle. This right here will be your angle of reference. This right here is your angle of reference. right? So you're going to use that. You're going to start there, and you're going to start labeling your figure. So across from 25 degrees, this side here is the opposite side. And then across from the 90-degree angle, this side is your longest side. We call that the hypotenuse. And lastly, this needs to be the adjacent side because it's next to the 25-degree angle. So there you go. But how do we find the value of x? Now remember what I said at the beginning, write your SOHCAHTOA. SOHCAHTOA. So let's go ahead and highlight the stuff that has information, that has some information that I can work with. Notice that I have an x here, that's the opposite side, and then this is the adjacent side, which is 18. And if we look closely at the hypotenuse, there's no given measures whatsoever, okay? The opposite side has a given measure, and the adjacent side has a given measure. So if I have opposite and I have adjacent, look at your SOHCAHTOA. Tell me which one should I use in this scenario. Because I have opposite and adjacent, which one has opposite adjacent? Here's OA, that's TOA. So that means I'm using the tangent function. So I write tangent of your angle of reference, which is 25, and that's equal to, again, tangent is opposite over adjacent, right? So I'm not going to write opposite over adjacent. Don't do that. Just write tangent of 25. It's the opposite side, which is x, and the adjacent side is 18. Okay, so don't write the over a. You're just going to confuse yourself. I guarantee you that. You're going to have tangent of 25 is equal to x over 18. This is an equation where I'm going to solve for x. How do I get x by itself? That's what I'm trying to do. Now, let's go ahead and go back to Algebra 1. I'm going to say 3 is equal to x over 2, right? So I have 3 is equal to x over 2. Y'all, to get x by itself, notice that this is division because it's x divided by 2. Now, what's the opposite of division? Well, that's multiplication. I need to multiply both sides by 2. So I have x over 2 times 2, or if I multiply across, I have 2x over 2. 2x over 2 is x on the right-hand side, right? And then 2 times 3 is 6, so x is equal to 6. Now, tangent of 25. Let me tell you this right now. The tangent, if I put this in the calculator, the tangent of 25 is a number. You're going to treat it as such. The tangent of 25 is a number. So if I'm doing the same thing, if I'm trying to solve for x, I got to do the same thing as I did before. So I can multiply both sides by 18. So these will go away. So I have 18 tan of 25 is equal to x. So then I know what x is equal to because it's 18 times this number here. So I'm going to write 18 times, okay, so this is where you got to figure out where the tangent button is, okay? If we look, okay, I'm going to try my best. I'm going to draw a little arrow. It's pointing to my calculator. Tangent is right there, if you can find it. You're going to press the tangent button, and you're going to input your angle of reference, which is 25. You hit enter, boom, it is approximately, and we're going to round to the nearest hundredth, okay? So this is approximately 8.39. That 3 after the 9 will dictate whether the 9 goes up or down, but in this case, since it's a 3, 9 is going to remain the same. So x is approximately 8.39. That is your answer. Let's look at this particular triangle. So 70 is my angle of reference. And then I'm going to start labeling. This is my opposite side. This is my hypotenuse. Why is it a hypotenuse? Because it's across from the 90-degree angle, and this is my adjacent side. Okay, so let's write so, ka, to, and then highlight the given information. So we have 15, that's adjacent, and then we have x, that's hypotenuse. So which one do I use? Which one has the adjacent and hypotenuse ratio? Ka, which means its cosine of 70 is equal to, so adjacent over hypotenuse, not hypotenuse over adjacent. You need to make sure that you are following the order. Adjacent first, then hypotenuse. So 15 over x. So 15 over x. Okay, so how do I get x by itself? Well, just like what we did before, we were multiplying whatever appears in the denominator, both sides, by the way. So we multiply both sides by 18, just so we can get x by itself. We're going to do the same thing. It's just going to be a little weird here. We're going to multiply both sides by x. Okay? So now look at this. The x's will go away, so we have x cosine of 70 is equal to 15, right? Okay. All right. What do I do now? How do I get x by itself for real? Now, remember, if I give you something like 3x is equal to 6, you know for sure you're going to divide both sides by 3, right? And that's going to be x equals 2, because it's 3 times this variable. Now, if you remember what I said about, the tangent of 25 being a number, it's just like the cosine of 70. Cosine of 70 is a number, right? So it's a number. This here is a number multiplied by x. So if I have a number multiplied by x, what do I have to do on both sides? We're actually going to have to divide both sides by this number. We're going to divide both sides by this number. Okay? So let's divide both sides by cosine of 70. So this will go away. We have x on the left-hand side, and that is equal to 15 divided by cosine of 70. Do you see what I did there? I'm going to do that again. So we have 15 divided by cosine of 70. So 15 divided by cosine, input 70, close it with the parentheses, boom, press enter. What is your answer? Your answer is 43 point, round to the nearest hundredth, so that 7 is going to dictate that 5, so it's 43.86, approximately 43.86, okay? And that is your answer for x. Okay, so let's take a look at the last page of the notes. If the unknown is the numerator, multiply. If the unknown is in the denominator, divide. Let's go ahead and find PR for this triangle. So it's referring to this side here. So that's PR. I'm not going to call that PR. I'm going to actually call that X. So let PR be X. This here is X, okay? And that's part of the given information because, that's here. That's my given. Okay, so let's take a look at our angle of reference. Where is the angle of reference? It's 30 degrees, right? So 30 degrees is my angle of reference. I'm going to use that. That's where I'm going to start so I can label the figure. So across from 30 degrees, this is my opposite side. So this is opposite, this is hypotenuse, and this is the adjacent side. All right, here we go. Right, so, ka, to, Note that since PR is a given information, I can go ahead and highlight that, or we called it X. And 16 is a given information, that's opposite. So I have opposite, hypotenuse, okay, that's so. So means I'm using the sine function. So I write sine of 33 degrees. That's my angle of reference. That 30 degrees is my angle of reference, which is equal to opposite over hypotenuse, okay? So it's 16 over x. And then I'm going to show you a faster way because this is very similar to what we did over here, where we had to multiply both sides by x and then divide by the function, the trig function. In fact, the shortcut is swap the x and the trig function, the positioning of the two. So sine of 33 will be in the denominator, and this x will be on the left-hand side of the equation. So x is equal to 16 over sine of 33. Okay? Now, this trick will work if the x or whatever variable is in the denominator. So I'm gonna write then. Trick works if x is in the denominator, okay? So now I'm trying to solve for x. I'm gonna put 16 divided by sine of 33, which is 29. So it's approximately 29.38. Okay, next problem. We need to find AB. AB is our given information. Let AB be x. So this is x. Now, find your angle of reference. This is my angle of reference. This is the opposite side. This is hypotenuse. This is adjacent. So writing SOHCAHTOA again. Which one do I use? So the given information, we have adjacent and we have the hypotenuse. So I will, okay, so I'm talking about adjacent and hypotenuse. Which one? So, co, or toa? It's this one, okay? Because we're talking about adjacent and we're talking about the hypotenuse. Nothing here. I can't use opposite. There's no given information for opposite. So don't worry about that. Let's go ahead and use ca. So ca means cosine of your angle of reference, which is equal to, and you know, you can put the parentheses or you don't have to put the parentheses. It's just however you're feeling. But if you're writing cosine of 62, you can or cannot, or sorry, you can or don't have to put the parentheses. That's what I'm trying to say. So cosine of 62 is equal to, what is we're dealing with? Adjacent over hypotenuse. So x over 10, not 10 over x. And since I don't have a variable in the denominator, I cannot swap the position of the trig function and the number in the denominator. So I gotta go ahead and multiply both sides by 10. Just like that example we did before. This one right here. Just like this. Okay, so let's go ahead and cross out the 10s, and you have 10 cos of 62. So 10 cosine of 62 is equal to, oh, okay, so that's approximately, so it's approximately 4.69. That's your answer. That's x, okay? All right, here we go. Last thing, if you have two legs and you need to find the angle measure, not the sides. I'm going to write this. I'm going to make this important. It's not the sides you're dealing with. Not the sides. Use the inverse trig function. And to do that, you use the second, which is the blue key, to get the inverse function. Inverse minus 1 function. Now, example, find the measure angle A and measure angle B using the inverse trig function. I'm not going to find both, but I'm just going to find measure angle A, where I want to save some time, but get to the point. So, to find the measure angle A, I'm not finding the sides. I just want to make sure we understand. I'm not finding the sides. I'm trying to figure out how long, so how long is this angle A is. So how long is the measure angle A? Question mark. So angle A being my angle of reference, oops, I did it again. Angle A being my angle of reference, I gotta label my figure. I have opposite, and then I have this is the hypotenuse, and this is adjacent. So, SOHCAHTOA. 6 is my given information, 20 is my given information. We have opposite, adjacent. That means we're using tangent. So I write the tangent of your angle of reference equals what's opposite? 6. What's the adjacent side? 20. Tangent of A is equal to 6 over 20. Now, you don't stop here. Again, you're trying to figure out how long the measure angle A is. And to do that, this is what we're going to do. Now, in Algebra 1, you were learning how to undo things, right? You were basically trying to say, oh, what's the opposite of this? What's the procedure of doing that? Like 2x is equal to 6, right? So I'm going to make a note. So if I say 2x is equal to 6, I got to undo the multiplication. And how do we do that? We got to divide both sides by 2. So that's x equals 3. Or if I have x plus 3 equals 6, this is my addition being involved. I got to undo the addition by using the inverse operation, where I'm going to say subtracting. Okay, see, the opposite of addition is subtraction, so I got to subtract both sides by 3, so x is equal to 3, right? So we're basically undoing. Just like over here, we gotta do the trig function, and to do that, we have to use our calculator. Look up here. Again, we're going to use the second button, which is the blue key. So press second on your calculator, and then find the function that we're dealing with. In this case, we're dealing with tangent. So you have second already pressed, then you're gonna press tangent, and it should look like what you see on the screen. So it's inverse tangent. So we have the inverse tangent of, so you can see we have parentheses involved on the calculator, or in the calculator. We're gonna write 6 over 20. So put 6 divided by 20 and hit enter. The measure of angle A. So how long is this angle here? Is approximately 16.7 degrees. Okay, let's do another example. We're going to use a different example here. I'm not going to find the measure angle B. I want to save some time, and I just want to get to the point. So let's look at this. We're going to find measure angle A here. And measure angle A, or the angle A, is my angle of reference. This is opposite. This is hypotenuse. This is adjacent. Note that my hypotenuse and my adjacent are the given information that I have on paper originally. So I have adjacent over hypotenuse. I love to write SOHCAHTOA. That's going to help us. So, not, so as in SO. What are we going to be using? I have adjacent over hypotenuse. That's ca. I'm dealing with the cosine function. So you have cosine of A is equal to adjacent over hypotenuse, 3 over 15. Okay? Again, I need to figure out how long measure angle A is. So I got to undo the trig function, and in order for me to do that, I got to press second, then the function that I'm dealing with, which is cosine. So you have to have cosine inverse, cosine inverse, and then you're going to input the ratio inside. So 3 divided by 15, right? Hit enter. So the measure angle A is how many degrees? 78.46 degrees. Or you can say 78.5. It just depends on what you're supposed to round, okay? So there you go. Trigonometry. That was fun. Hey, I'm back. So do you remember that I crossed out measure angle B for no reason? Y'all, if you found what measure angle A is, and you have a right triangle, look at this. You have 16.7, which we found before. This is 90 degrees, so I can figure out what measure angle B is by, the sum of the interior angles of a triangle. It's this plus this equal to 180, right? So to figure out measure angle B, again, I'm just going to do 180 minus 16.7 minus 90 degrees. So let's put that in our calculator real fast. 180 minus 16.7 minus 90. Press enter. Okay, so measure angle B is approximately 73.3 degrees, okay? So that's the answer. So there's measure angle A, and then there's measure angle B. Let's take a look at this one. Okay, so we found out for this problem, this is 78.46 degrees, right? And then you have 90 degrees here. So what's the measure angle B? Well, you know the sum interior angles of a triangle is 180, so I do 180 minus 90 minus 78.46. Hit enter, that's 11.54 degrees. Or measure angle B is 11.54 degrees. Okay, there you go. Sorry, I don't know why I crossed out measure angle B. I think when I was looking at this at first, I was like, oh, I think I have to do some trig and setting up the problem and figuring it out that way. I mean, you can, that's technically correct, you can do that, but this is probably the easier way to figure out measure angle B if you have measure angle A and the other angle, right? Hopefully this makes sense. Bye bye.